For any complex number z1, z2, the maximum value of this we have to find out. We know already the real part of z is always less than the mod z. We know it in the basic complex numbers properties. We can write this one as 2 times of real part of z1 into z2 bar upon mod z1 into mod z2. This is one complex number. Another complex number is always less than, that is modulus of z1 into z2 bar upon mod z1 into mod z2. That is 2 times, because here 2 times carried out. So therefore, this is mod z1 into mod z2, modulus of z1 into z2, mod z1 into mod z2 bar, both are same, get cancels. Therefore, the answer is what? 2. Hence, the maximum value of this complex number is given to be what? 2. Yes. Question. If modulus of z plus 2i is less than or equal to 1, z1 is equal to 6 minus 3i, then the maximum value of iz plus z1 minus 3. Okay, let us consider this only. What I do is modulus of iz plus z1 minus 4. Yes, iz, z1 you substitute, it becomes 6 minus 3i minus 4. This becomes iz 2 minus 3i. But our complex number is given to be z plus 2i. What I do is add and subtract. Okay, add and subtract 2, right? This becomes 2 minus 3i, right? 2 plus 2 minus 3i plus 2. Original 2 is this only, right? As it is. This 2 is add and subtract. This becomes I into, yes, modulus of, okay, I into z plus 2i plus 4 minus 3i, okay, by adding and subtracting 2. So therefore, this is less than or equal to, right, mod I, modulus of z plus 2i, okay, that is into modulus of this is plus modulus of 4 minus 3i. This is nothing but 1. This is also 1, this is also 1, this is nothing but 5. So therefore, the maximum value is 6. In this question, we are given with z1, z2, z3 as 6th root of 1 minus I upon 1 plus I root 3. z2 is equal to 6th root of 1 plus I upon root 3 plus I. z3 is equal to 6th root of 1 plus I upon root 3 minus I. Which of the following holds good? The very first option is mod z1 whole square, sigma mod z1 whole square is equal to 3 by 2. Option B, mod z1 whole power 4, mod z2 whole power 4 is equal to mod z3 upon minus 8. Okay, next, that is option C as mod z1 plus mod z2, mod z3 is equal to z2. So later, we have to verify the D as mod z1 into mod z2, right? Mod z1 into z2. So let us see. What is the first one? Mod z1. If I get into the solution of this, mod z1 is equal to, yes, this becomes 1 minus I. Square root means we have to find out modulus, that is root 2 upon 2, 1 by 6. I have found out the modulus. How comes modulus of z1 by z2 is nothing but mod z1 by mod z2. This is nothing but 1 by root 2 power 1 by 6. This is nothing but mod z1 is equal to 2 power minus 1 by 12. Similarly, you get mod z2 is equal to same minus 1 by 12, and mod z3 is also 2 power minus 1 by 12. Yes, verify that. So therefore, if you verify this, we are going to get, that is option B. we have to find out the square root of a complex number. I take this 4ab as a plus b whole square minus a minus b whole square, right? So therefore, I can write this one as a plus b whole square plus I into a minus b whole square, right? Minus, as it is, a minus b into a plus b into I. This can be written as, if I take this as I square, it becomes a minus 1. Once again, we are coming to the standard result. This becomes a plus b, okay, minus I into a minus b whole square, right? Whole square. This becomes plus or minus a plus b minus I into a minus b is the required square root of a given complex number. For all complex numbers z1, z2 satisfy mod z1 is equal to 12 modulus of z2 minus 3 minus 4i is equal to 5, then minimum value of this we have to find out. Okay, we know that already modulus of z1 minus z2 is always greater or equal to mod z1 minus mod z2. I will write modulus of z1 minus z2 is nothing but modulus of z1 minus of z2 minus 3 minus 5. Okay, add and subtract. This becomes 3 plus 4i. Add and subtract. This becomes, that is modulus of z1, modulus of z2 minus 3 minus 4i, modulus of 3 plus 4i. This is given to be already, it's a what? A 12. This is given to be 5. Square root of modulus of this complex number is nothing but square root of 9 plus 16 is nothing but 5, is nothing but 2. Therefore, the minimum value is given to be what? 2. Yes, dividing f of z by z minus I, we obtain the remainder as I. And dividing f of z by z plus I, we get the remainder as 1 plus I. Then the remainder upon division of f of z by z square plus this dash. By using division algorithm, f of x by g of x, yes, I can write this one as f of x is equal to g of x into q of x plus r of x. By using this division algorithm, what I write is f of z is equal to g of z into, that is z plus I into z minus I plus az plus b is the remainder. This is the quotient. What's the quotient? Z square plus 1. By using what is data, he has given f of I is equal to, I has given y. By dividing f of z by z minus I, by using remainders and factors theorem, f of I is equal to I. Similarly, f of minus I, this is equal to how much? 1 plus I, right? Take this value, substitute here. This becomes I is equal to 0 plus, if you put z is equal to I, this becomes 0. Therefore, this is ai plus b. You call it as 1. Next, similarly, it becomes 0. This becomes minus ai plus b is equal to 1 plus I. You call it as 2. Solve 1 and 2. You get, that is a as, that is a is equal to I by 2 and b is equal to, after adding, this becomes 1 upon 2 plus I. So therefore, what is your remainder? The remainder is nothing but az plus b. Substitute, it becomes I by 2, okay, into z, okay. If you want, you can put z plus 1 by 2 plus I is the required answer. Students, in today's class, we discuss about algebra of complex numbers, conjugate complex numbers, problems on iota, and how to find out the magnitude of a complex number. This is one of the important chapter for all types of examinations. So therefore, certainly you'll be expecting minimum 3 to 4 classes on this chapter. You'll definitely enjoy the varieties of problems that will bring you the good concept levels for your perception. Let us begin with the very first problem is, if the sum of the squares of the roots of x square plus p plus iq into x plus 3i is equal to 0 is 8, okay, then p comma q is equal to dash, right? Now if I take this one as, it is alpha comma beta be the roots, right? Now if I take this alpha comma beta as the roots of this quadratic equation, the sum of the roots, you know it already, p plus iq, right? And alpha into beta is equal to how much? 3i, okay? Now he has given the sum of the squares of the roots. It means that alpha square plus beta square is equal to 8, which means that alpha plus beta whole square minus 2 alpha beta is equal to 8. Come on, substitute. This becomes alpha plus beta, that is p plus iq whole square minus 2 into 3i is equal to what? 8. Now expand this p square, I square is equal to minus 1, it becomes q square, 2 into pq into I minus 6i is equal to 8, okay? Crib means, what is crib? Compare the real part and the imaginary part. So therefore this becomes p square minus q square is equal to 8, okay? Next it comes to 2pq minus 6 is equal to 0, therefore pq is equal to 3. Now this becomes p minus q into p plus q, yes, is equal to 8, okay? You can very well observe, yes, p is equal to plus or minus 3, q is equal to plus or minus 1, that's it. Yes, this problem represents an example on iota, that is I plus 2i square plus 3i cube up to some 100 terms is equal to dash. If you observe this problem, the terms of the series neither in AP nor in GP. In that case, better go with a method of difference as we come across in sequences and series. Now what I do is, I take this as s is equal to the given problem, that is I plus 2i square plus 3i cube and so on. I will write this one as 100 into I power 100, 1, 2, 2, 3, 100, 100. So therefore, what I do is, I multiply with the I, leave the one term gap. So therefore, you start with, that is I into I square, 2i into, that is 2i square into I, it becomes 2i cube, and so on. The term previous to this, preceding to this is 99 into I power 100, that is 99. If you multiply with I, it becomes 100. This is as it is. This becomes 100 into I power 101. Method of difference, find its difference. If I subtract, this becomes 1 minus I into s. This is nothing but I. This becomes I square. This becomes I cube. Now this becomes I power 100 minus 100 into I power 101. Yes, these terms are in GP. If I take out I outside, it becomes 1 plus I square. It becomes I power 99 minus 100 into I power 100, that is 100, okay? But you know, I square is equal to minus 1. I power 4 is equal to 1, correct? So therefore, this becomes I into, that is A into 1 minus r power n by 1 minus r, 1 minus r power 100, that is I power 100 upon 1 minus I, that is a is what? 1 into a into 1 minus r power n by 1 minus r, minus 100 into I power 100 becomes 1. Why? Because this becomes I power 4 upon 25, right? So therefore here 1 minus n to s, so therefore s is equal to, what is I power 100? 1. So therefore this 1 minus 1 becomes 0, total value is 0. Therefore this becomes 100i, 1 minus I cross multiply, that's answer. This question we are given with, if a power mod z square minus mod z plus 4 upon 1 plus mod z square into log 2 base e is equal to log of modulus of 3 root 15 plus 11i base root 2, then z we have to find out in terms of cis theta form. Okay, now you can very well observe this is in the form of e power p log m power p you can write, right? So therefore this becomes p log m is equal to log of m power p is the one concept, and later select z is equal to r into cis theta cos theta plus I sin theta. If I take modulus, it becomes r mod z is equal to r. Why? Cos square theta plus sin square theta is equal to 1. Then your given problem becomes, that is r square minus r plus 4 upon 1 plus r square into, this becomes log 2 base e, right, is equal to log of 2 power base f into square root of, this becomes 9 into 15 plus 121. I have taken the modulus of a complex number. So now p log m, as I said earlier, this becomes log of 2 power, this is r square minus r plus 4 upon 1 plus r square, right? Base e, right? Base e is equal to log of, this becomes as 121 plus 9 into this. This becomes, after simplification, it leads to the value of this one as 16. Okay, this becomes 2, that is 9 into 15 plus 121. It becomes 16, that is 2 power 1 by 2. So later, now, so e power, that is log x base e is nothing but x. This becomes 2 power r square minus r plus 4 by 1 plus r square. This becomes the another formula, log of a power m b power n is nothing but m by n into log a base b, right? So therefore I can write this one as, that is a 2 power 4 you can write, it becomes 4 into 2, right? It becomes log 2 base 2, right? Log 2 base 2, it becomes 8. So therefore now I can write this one as 8 into, now this becomes 8, 8 is nothing but 2 cube, log 2 base 2 is 1. Now compare the powers. Whenever bases are same, you can compare the what powers, right? Therefore after simplifying this, r square minus r plus 4 by 1 plus r square is equal to 3. It leads to r is equal to minus 1 comma 1 by 2.